Chapter 1, Section 5 is all about scatter plots. A scatter plot is a graph of points relating two groups of data, and it usually looks like this with a bunch of points in it. We tend to just use the first quadrant of the XY coordinate plane because it has positive x's and positive y's, and that tends to be where most of our data falls. And then there's correlation. Correlation is how two things are related. So if something has a positive correlation, both sets of data increase together. One goes up, the other goes up also. Negative correlation is kind of the opposite. As one data goes up, the other one goes down. And then no correlation, the two data sets aren't related. As one goes up, the other one doesn't do anything really of note. And then we sometimes use a trend line on a scatter plot. A trend line would be if I had a bunch of data and then a line kind of connecting some of the data. It tries to follow the data, and that lets us see a correlation a little better than just by glancing at all the dots. So there's only one objective for this lesson. It's kind of short. Your objective is to analyze data using a scatter plot. So would you expect positive, negative, or no correlation for the following data sets? The amount of free time you have and the number of sports you play. I tend to look at the two separate things that we're talking about, so the amount of free time and then the number of sports, and say, okay, what if one of them goes up, what if one of them goes down? So if the number of sports I play goes up, usually that means the amount of free time I have would go down. So as one goes up, the other goes down. This means it's a negative correlation. The sale of snowblowers and the inches of snow. So again, look at your two things. And let's say the inches of snow increase. What do you expect to happen to the number of snowblowers people are going to buy? Well, chances are they're going to go up. So they both increase. This means it has to be a positive correlation. The age of a student and the color of her hair. So if we talk about the two things, the age of student and color of her hair, let's say as the age goes up, we have no idea about the color of her hair. It could go in all different ways just because there's no correlation with those two things. Alright, now we're going to create a scatter plot for the data. So if we look, we have lengths and wingspan of a couple different type of hawks. All of these things right here are basically points. So we have an x and a y. Usually we make the first thing in the table the x values and the second thing in the table y values just to make our life a little easier. So now we have to plot them on a graph and then answer the question here. So if I'm going to put my lengths down here on the x-axis, we have a range in between 16s are smallest and 24s are highest. So let's count by 4s. 4, 8, 12, 16, this one's 20, 24, 28, don't have anything higher than that. And then the other side is going to be our wingspan. And for the wingspan, our lowest is 31, our highest is 46. Let's count by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And now we just get to put these points on the graph. So over 21 up 36 is going to be somewhere here-ish. 2141, same line, just a little higher. 1838 is going to be right in the middle here, up here. 2446, right on this line, just a little bit above there. 1631 on this line, right above the 30. 1939, somewhere right in here. 1735, be right there. And then finally, 1946. So if we take a look at our dots here, we can kind of see that as the lengths go up, in general, so does the wingspan. We could draw a trend line that kind of went through the data somewhere like here-ish. It goes up. So what kind of correlation is there between the length of a hawk and its wingspan? We're going to say a positive correlation, which means that as the length of the bird increases, the wingspan also increases, for the most part. So that's it. Can you prove it? Can you analyze data using a scatter plot? So I've given you a scatter plot. You need to come up with some sort of situation that might fit the correlation seen in this graph, and you cannot use the thing that we just did.